Hi, and welcome to our first renewable energy session, the first session of Fascinate. I'm Danielle.
And I'm Sarah Jane.
How many of you have ever caught sight of a large wind turbine in a field whilst in the car?
Perhaps you've seen large black solar panels on the roofs of houses in your local area, or even a little one at the top of a calculator.
But have you ever wondered how they actually work?
In this session, we're going to explore what is energy, where do we find it, and what do we use it for,
The different types of energy?
and why renewable energies are important for our planet.
Most importantly, we'll be having a go at making our own miniature renewables with pinwheel turbines and our own water wheels.
Before we start thinking about renewable energy, the big question is, what is energy? And actually, it's very simple to understand. Energy is simply the ability to make something happen. There are many different types of energy, and there are lots of examples all around us.
Let's start by looking at ourselves. We need lots of energy to help us move around and keep our bodies functioning well. And we get this energy from the food we eat. This is why you often start to feel tired when you're hungry. It's because you're running low on your energy stores. And equally, you might suddenly feel ready to run a marathon after you've eaten some sweets, because sweets contain a lot of energy.
We also need energy to power things we use every day, and this includes the heating and electricity in our homes, our cars and public transport, and lots of appliances, including the device that you're watching us on right now.
Obviously, you can't give your car a big roast dinner to power it through a long journey, so we have to find alternative industrial energy sources that cars and other appliances can use in order to work properly.
And this brings us to the focus of today's session. Traditionally in the UK and around the world, industrial energy supplies have come from energy stores deep under the ground, called coal, or deep under the sea, called oil and gas. And these are called fossil fuels. Typically, we would collect them and they'd be burned in a big power station in order to release their energy.
Although these sources hold lots of energy, which is great for our cars and heating our homes, there are two main problems with them. One, we will eventually run out of them. There is only a limited supply held within the ground, so when they run out, we're going to have some serious problems. And two, they're not very good for our planet because they must be burned. This releases nasty pollutants and gases into the Earth's atmosphere, which hurts plants and wildlife. These gases also contribute to something called global warming, which is the way the Earth's temperature is gradually increasing. And this is bad news for us and all the other creatures we share the planet with.
So scientists quickly realised that we were going to need an alternative way to power our lifestyles. And so renewable energy sources were born. Renewable just means that it won't run out. So let's cut back to earlier when we said that there were lots of different types of energy. The food we eat and the coal, oil and gas used in power stations would be considered chemical energy, a type of energy which is eventually going to run out. But there are lots of other types of energy, such as wind energy, light energy, heat energy, and water energy. For this session, we're going to focus on wind energy and water energy.
Wind energy is really cool. It's completely invisible, although you will be able to feel it if you're outside on a windy day. It can be used to power lots of things, such as a flag at the top of a flagpole, to keep a kite or paraglider in the air, or to allow a boat with large sails to move over the waves. Wind energy can also be used to power our homes, with electricity using wind turbines. To demonstrate how wind turbines work, we're going to make our own pinwheels. For this, you will need a square piece of paper or some A4 paper that we will make into a square, a wooden dowel or a paper straw, some glue, some scissors, some push pins, some spare paper that you've got lying around, and a pencil. Let's start by making our A4 paper into a square. To do this, you need to take the corner of the piece of paper and fold it diagonally across to the other side of the piece of paper, like so. Then you want to fold along the crease. The next step is to use scissors and cut off the extra bit of paper at the end. We won't be needing this. As you open out your paper, you have your square ready to use for your pinwheel. To make your pinwheel, start by folding your square piece of paper in half diagonally both ways. With your folds marked, use a pencil to mark halfway up each fold so that you know how far you need to cut with your scissors. Now use a pair of scissors to cut up to the point you have marked. Next, you need to put some glue in the centre of your piece of paper where the folds meet. Then fold one half of each point into the centre. After you've stuck it down, place some more glue on top of it so that the next point will stick on top. When the final point is attached, hold your finger down for a few seconds to make sure that all the points stay together. Now we're going to make a small circle of paper to go in the centre of our pinwheel, so we need this scrap paper that we found earlier. Start by drawing around something circular, such as your glue stick. And then cut it out using a pair of scissors. A piece of blutac or plasticine will be helpful for this next part. Place your plasticine or blutac at the point where the folds meet on the back of your pinwheel, then put it flat on the table with the front facing you. For the next step, you'll need one of your push pins. Place your circle of paper into the centre of your pinwheel, and then carefully using the push pin, push through all the paper into the blutac or plasticine below. When your push pin is attached, carefully remove your pinwheel from the plasticine below. Try not to rip it. You can remove any residual bits of blutac or plasticine from around your pin using the larger piece. For this next part, you'll need a separate push pin and a paper straw or a wooden dowel. We're going to make a hole in our paper straw so that our pinwheel can be attached. For demonstration purposes, I've shown this close to the camera, but it's much easier and safer to do flat on a table, which is what I'd recommend. Once you've made the hole, remove the push pin so that it's ready to attach your pinwheel. Once your pinwheel is attached to the straw, you should be ready to go. You can take it outside and test it out just like a turbine. Hopefully your pinwheel will spin around as the wind picks up. This works in a similar way to a wind turbine, except the turbines operate on a much larger scale. As the wind blows, it creates a force, or wind energy, which is powerful enough to turn the blades of a wind turbine, just like on your pinwheel. As the blades of the turbine spin, it powers a generator inside the turbine, which generates electricity. This electricity can then be transported through power lines to our homes, where it can be used for things like lighting, cooking, and charging our devices. There are lots of great reasons why wind energy works so well. Number one, although there are costs for setting up the turbines, the wind itself is completely free. Number two, the wind isn't going anywhere anytime soon, so it's an energy source which won't run out. And number three is that there are no harmful polluting gases created, and it's great news for the planet. You may have also noticed when testing out your pinwheel that there are some problems with wind energy. Number one is that if you're trying this on a still day with little wind, you're probably not going to have much success with your pinwheel. And this shows one of the main problems with wind energy, is that the amount of energy generated is entirely dependent on how windy it is on that day. And if there's no wind, there's no electricity. If you've ever been close to a wind turbine, you may notice that they can be quite noisy. But overall, wind energy is a great alternative way to power our homes, which is better for our planet. Now we're going to take a look at another, water energy.
Unlike wind energy, water energy is a bit more visible. It's caused by the movement of water. Let's think about a water wheel. As water falls onto one side of the wheel, it collects into one of the cups, and that side of the wheel becomes heavier. This causes the water wheel to turn round. As the water wheel turns round, that cup empties, but the one above it is filled up with water. This cup then is going to be emptied, and the process is repeated, and the water wheel keeps on turning as more cups are filled up and more cups empty. This rotating energy can be used to power lots of different things. First water wheels were used in mills to grind flour. 2 millstones would be placed on top of one another. A millstone is a big circular stone like a donut, but flat on the top and the bottom. Wheat would be placed between the 2 stones like a sandwich. As the water wheel rotated, it would turn one of the millstones, grinding the wheat to flour. Then in the Victorian times, water wheels were used to power machines in mills to make clothes. And now, water energy from the sea is used in tidal power stations to generate electricity. We're now going to make our own water wheels and see how they work. To make your water wheels, you'll need 2 paper plates, a small blob of blutac, a pen, some split pins, a wooden skewer or dowel, or a round pencil will do, and 6 paper cups. I'm going to start by making the holes in each of my paper cups. Each cup is going to have 4 holes in it. The first one is going to be a couple of centimetres below the rim, and the second one a couple of centimetres below that. I'm then going to turn my cup around, and the next one is going to be a couple centimetres below the rim again, and a couple centimetres below that. So you'll have 4 holes in your cup. To make the hole in my paper cup, I'm going to place the blutac on the inside of my paper cup below where I've marked the hole. As you can see, I've stuck it on the inside. Now you may need an adult helper for this bit, because now I'm going to use my pen and poke through the hole onto the blutac. You might need to be quite strong to this bit, and mind your fingers, and you see I've made a hole. I'm going to do the same thing again, put the blutac underneath where I'm going to make the hole, and then keeping your fingers out of the way, push down on the cup and make your hole. And then going to do the same on the other side. So now my cup has got 2 holes on that side and 2 holes on the other. We're now going to repeat that for each of our 6 cups. We're now going to make the holes in our paper plates. I'm going to start by marking where I'd like the holes to go. Each of the cups is going to be spread evenly around the rim of the plate. This means we've got to mark 6 sets of 2 holes. I'm going to start at the top by making 1 hole near the rim and then 1 a couple centimetres below it. And then I'm going to go opposite the plate and put 1 hole at the bottom and 1 at the rim. I'm now going to turn my plate about a 6th and do the same again. So 1 hole near the rim and 1 slightly below it. And then I'll go opposite and 1 near the rim and 1 slightly below it. And then finally, we'll turn it round again and do the same. 1 hole near the rim, 1 slightly below it. 1 hole near the rim and 1 slightly below it. Now to make our holes, I'm going to use the blutac and the pen again. So I'm going to put my blutac on the table, and this time I'm going to place my paper plate on top of the blutac and push down with the pen to make the hole. Like that. And as you see, I've made the hole in my paper plate. Then I'm going to do the same for the rest of the holes. Remember to be careful with your fingers at this part and keep them out of the way from underneath your plate. If you need any help, make sure to ask an adult helper. I've got 12 holes in my paper plate, and I'm going to do the same for my second one. Now that I've got 2 paper plates, each with 12 holes in them, I want to make 1 final hole in the centre of each of them. This is going to be for the skewer that will go through the middle. To do this, I'm going to make the hole at the same time and put both paper plates on top of each other. This will make sure that they're in the same place on both of the plates. I'm then going to mark a hole in the centre of my plate. And I'm going to do the same thing again. I'll put the blue tack underneath my plate and place the plate on top. I'm next going to use the pen to just make that hole. So now we've got 2 paper plates, each with 13 holes in them, and we've got 6 paper cups, each with 2 holes on either side. And we're ready to start making our water wheel. I'm now going to start to make the water wheel. To do this, I'm going to attach each cup to the first plate using the split pins. So you can start by taking one split pin and putting it through one hole in the cup. So it should look like this. I'm then going to put the split pin through one of the holes on my plate. Once it's through, I can turn the plate over and separate the pins to fix it in place. I'm then going to do the same with the second hole on the inside. It should then look something like this. I'm then going to repeat it to attach each of the 6 cups to my first plate. By putting the split pin through the hole and then attaching it to the plate. Once you've finished, your water wheel should look something like this. I'm now going to attach the second plate. I'm going to start by placing it on top and lining the holes with my cups. Then taking a split pin, and this time I'm going to push them through from the plate and to the inside of the cup. So I'm going to put it through a hole on my plate, so it's like that, and then through the hole on the cup. I can then spread out the legs of the split pin, so it looks something like that, and my plate's attached. I'm going to start by doing the outer ring of the holes. It doesn't matter if you can't fit the second ones in. They're useful to stop the cups from spinning, but if you can't fit them in, don't worry. Then your water wheel should look something like this. The final job is to fit the skewer through the middle. I'm going to start by poking it through the top plate. And then if you turn it on your side, you can just see the skewer in the middle. You want to direct that through the other hole, but be careful, don't put your fingers near the other side as you don't want to hit them with the skewer. There you go. So my skewer's through the other side, and now I've got my water wheel. It's ready to spin, and we'll go and test it out. I'm going to test my water wheel in my sink, but you can use a jug and pour water on it. Just make sure to have a bucket underneath. Or if you don't want to get wet, you can use rice instead. So let's turn the water on and see what happens. And here it is, my water wheel spinning. Well done on making yours. I hope that yours is spinning too. Let's slow it down and see what's happening. As the water falls into the water wheel, the cup gets heavier, which means it falls down. That turns the wheel and the next cup's filled up. This keeps on happening and our water wheel keeps on spinning. It will keep spinning as long as we have water falling onto it. Hopefully by making your water wheel, you've seen what a powerful source of energy water can be, but it does rely on some things. One, you need to have a flowing source of water. And if the wheel is big, it's going to need to be large to be able to move all of that weight. The water needs to be reliable too. You don't want to risk the river drying up in summer or it being too shallow. That's why in coastal areas, tidal power plants in the sea use water energy from the waves to make electricity. We can rely on the sea and we know the tide times where it goes in and out, so we can easily predict when we're going to get the electricity. I hope that you've enjoyed making windmills and water wheels with us today, and that you've learnt a bit about renewable energies too.
There's a lot more to come during Fascinate this week, so make sure to check out the programme on the website, and it would be great for you to join us soon.
Bye!
Bye!